In today's video, you'll be learning about three interesting integrals. Now, the first integral we'll be solving is this. So, the cosine squared of 2 of x dx. Now, how exactly do we solve this type of integral? Because cosine squared of 2x seems at first a very tedious integral. But there's actually an identity we can use, and it relates to the one that is cosine squared is equal to 1 plus cosine 2 of x. Let me just write that properly. Cosine 2 of x over 2. Okay, so here we have a problem, right? Because we have x here, cosine squared of x is equal to the identity, but in the integral we have cosine squared of 2 of x. Well, that's not actually a problem because we can treat 2 of x as the actual angle, and then as a result we have our equation cosine of 2 times 2 of x, because in this case we're treating x as 2 times x. So, which means our result would be 4x, because 2 times 2 of x, because 2 times 2x would be 4x. Okay? Over 2. Now, this becomes the integral of 1 plus cosine 4x of over 2 dx. Okay? We can pull out the 1/2 here, and this becomes the integral of 1 plus cosine of 4 of x d of x. Right? And then now it's 1/2 x. Now we start integrating it. Plus, now what is the integral of cosine of 4x? Well, most people here will just use substitution. I'm telling you right now, you don't have to do that. You can just kind of say, well, there has to be a 1/4 outside the actual integral of it, because the derivative of 4 would just be, the derivative of 4x would just be, well, 4. So 4 times 1/4 would be 1. So in that way, there would be something to cancel out in order to get the cosine 4 of x. So there has to be 1/4 here. Now, what derivative would give you cosine? Well, sine would. So we have sine of 4x. Okay, and I bet, yeah. So sorry, 1 second, I made a mistake here. So it would actually be not just that. It should be 1/8, because I forgot about the 1/2 here. Okay, so 1/2. So yeah, 1/2 times x will give you 1/2. We have 1/2 x, and then 1/2 times the integral of cosine of 4x will just give you 1/4 times sine of 4x, and then yeah, 1/2 that would be 1/8. Okay, and remember to put the plus c here. So that's your answer. Okay, that's your answer. Okay, now you're going to have the integral of x times sine squared x. Now, how do we go about doing this? Well, as you can see here, we can actually apply the same method we did earlier, which is the sine squared identity. Now, the sine squared identity is similar to the one I showed previously, the cosine squared identity, because all it is just 1 minus cosine of 2 of x instead of 1 plus cosine of 2 of x. Okay, so that's all it is. Just the signs are opposite. Okay, so when we do that, we're going to get x times x minus x cosine of 2x dx over 2. Okay, and now this is going to be equal to 1/2 of the integral of x minus x cosine of 2x. Okay, and now Now, how do we go about solving this? Because we have x here times cosine of 2x. Well, for this part here, you can just use integration by parts. Okay, so I guess when there's some tactics to avoid integration by parts, do them, because integration by parts can take a while. But here, I think it would be best to use integration by parts. So, alright, our u is just going to be x according to Liot, and Liot, L, or Liot, however you want to say it. A comes before t, algebraic trig, so x would be our u. dv would be of cosine 2 of x, and then du would be dx there, my bad. And then v would just be, the integral of dv would just be 1/2 times sine of 2x. Okay, now 1/2 times, my bad, so yeah, so 1/2 x times sine of 2x minus the integral of, okay, the integral of sine of 2x, right? So I just put out the 1/2 there. So this will just give you 1/2 x sine 2x of, of negative 1/2 times cosine of 2x. Now the reason it's negative is because, well, the derivative of cosine is just negative 2x. Okay. The derivative of cosine is just negative sine of 2x, and then the negatives, negative 1/2 with negative sine 2x would just cancel out, and then the derivative of 2x would just be 2, so that would cancel out with the 1/2, and then you would get sine of 2x in the end. Okay, so now overall this will just give you 1/2 x sine 2x plus 4 cosine of 2x. Okay, now, yeah, and if you want you can put plus c here, but it doesn't matter. So, which means that our answer would just be 1 times, okay, so yeah, so our answer would just be 1/2, okay, yeah, I was right like this, 1/2 times the, yeah, so the expression of minus, yeah, so it's the minus 1/2 here, sine of 2x, and then, okay, and then minus, minus cosine of 2x here, okay? So, and then when you compute all this, you would get a final answer of 1/4 x squared minus 1/4 x sine of 2x minus 1/8 of cosine of 2x. Yeah, so a very long integral here. And then you want to do plus c. Don't forget that plus c. So this is our answer right here. Okay, and answer. Okay, now let's move on to the next and final integral. So our final integral is just 3 over x squared plus 4x plus 29 dx. Okay, so how exactly do you solve this integral? Well, before I solve it, I would like you to give it a try, because it's actually a very interesting integral to solve. Okay, so pause the video and see if you can solve it. Now, first off, we can just bring out 3, right? That's always a good first step to take. Bring out any constants. Of x squared plus 4 plus 29. Okay, so that's what we have so far. Okay, now we've done that, we can complete the square here. Remember that method, completing the square? Okay, so when we come to this square here, we're going to get I think it would be, yeah, so it would be x plus 2, okay, yeah, x plus 2 squared plus 25, okay, when you come to the square. And yeah, we know that because 2 times 2 is just 4, plus 25 is just equal to 29. Now, we have a very interesting integral here, because we know that the integral of a tan function is just, sorry, yeah, the derivative of a tan function is just this, right? And most of you here would see that it actually looks very, very similar, right? 1 over x squared plus 1 is similar to 1 over x plus 2 squared plus 25. Now it turns out that we can actually just sort of, there's this kind of formula, right? Which is the integral of these types of functions here is just going to be equal to 1 over tangent, sorry, it should be tangent inverse here, my bad. Tangent inverse of whatever x is, so yeah, whatever x is, so we just put x here, or we'll just call it u, yeah, we'll call x u, so u over a. In this case, u would just be, u here would just be equal to x plus 2, okay, so that means our answer would just be 3 times 1/5 times tangent inverse of x plus 2 over 5. Now why is it 5 I'm putting here? Well, it's because we can rewrite this expression here, okay, as 1 over x squared plus 2 plus 5 squared. And the a value in this case, as I put in this formula here, the a value here is just basically the constant. It's just the plus constant, right? It's whatever x squared plus what constant, whatever it is. Yeah, plus these whatever square of the constant. So the square root of, yeah, it's just basically plus whatever the square root of that constant is. So the a value would just be the square root of that constant. So the square root of that 25 is just 5. So that's why it's just 5. So then our answer here would be 3 over 5 tangent of inverse of x plus 2 over 5. Okay. Now there's a whole bunch of these these types of formulas here, and I really think you should memorize them because they're actually very, very helpful in whenever you solve complex integrals. Sorry, let me just make this more clear. Make the a's and u's more clear here. So it would be u over a. Okay. So yeah, just memorize these types of formulas here, so that whenever you run into, say for example, in this case, x plus 2 plus 25, you'll be able to solve them. In other cases, right, we have 1 over square root of 1 minus x. Sometimes here, the 1 would be a 25, and sometimes here, the x would be x plus 2, as in this case here. So whenever that's a problem, well, it's fine, because we know that the derivative of sine inverse would actually give you this function here. So in this case, right, you would have to use another formula. You would have to use another formula of the tangent formula here, as I shown here. So yeah, overall, just memorize all of those formulas, and you'll see that you'll be much better at integral solving with trig. Okay, I hope you enjoyed that video, and I'll see you next time.